So today's class is on numericals on intensity. This class is very much helpful for BSc student. So all students are requested to watch the video and practice at home again and again. So first we have to calculate the intensity level. Here in two cases are given. First, that is intensity level. Intensity level, that is beta equal to 10 log 10 base I by I0. This is in unit of dB, that is decibel. So here we have to calculate, that is intensity level. So 10 log 10 base, here I is given, that is I is given 1 microwatt meter to the power minus 2, that is I 10 to the power minus 6 watt meter to the power minus 2. So 10 to the power minus 6 by 10 to the power minus 12. So we can write that is 10 to the power 6. So that is 6, that is log, that is 60 into 1, that is 60 decibel. So second part, that is 50. Here that is beta equal to 10 log 10 base I by I0. Here intensity level is given, that is 50. So 10, this is log 10 base. So we can write I by I0. Here we get, that is log 10 base I by I0, this is 5. Using the relation of log, so I by I0 equal to 10 to the power 5. So I equal to 10 to the power 5 into I0, that is 10 to the power 5 into 10 to the power minus 12. So I equal to 10 to the power minus 7 watt meter to the power minus 2. We have to remember the value of I0, that is standard value, that is 10 to the power minus 12 watt meter to the power minus 2. So this is the standard value we have to remember. Next, I come to the next problem. Here a source is given. So a source emits a sound with power output 40 watt, and we have to calculate the intensity at a distance 2 km from the source, assuming it to be a point source. Calculate the intensity level in dB. So first, that is we know, that is I equal to P by, that is 4 pi r square. P is given, that is P equal to 2 watt. R is given, that is 2 kilometer, that is 2 into 10 to the power 3 meter. So we can write I equal to 2 by 4 pi, that is 2 into 10 to the power 3 tar whole square. So this is 7.962 into 10 to the power minus 7 watt meter to the power minus 2. So that is intensity level beta. We can write 10 log 10 base I by I0. So I is given, this is the value of I. So 7.962 into 10 to the power minus 7 by I0. I0 means that is 10 to the power minus 12. So we get the value that is 10 into 5.9010. This is the value. So we get that is 59 dB. dB means that is decibel. So intensity level, so hence intensity level is 59 dB. This is the second part, and first part, that is intensity at a distance 2 kilometer from the source. This is 7.962 into 10 to the power minus 7, that is watt meter to the power minus 2. This is the two answers of these problems or of these numericals. Noise from aeroplane engine 100 meter from observer has intensity level 90. What will be the intensity level when the plane flies overhead at an altitude 1 kilometer? So from inverse square law, we know I proportional 1 by r square. So first case, I1 proportional 1 by r1 square. Second case, I2 proportional 1 by r2 square. So we can write I1 by I2, that is r2 by r1 tar whole square. So r2, that is 10 to the power 3, that r1, that is 10 to the power 2, this is whole square. So we can write r2, that is 1 kilometer. 1 kilometer means 10 to the power 3 meter, that is r1 100 meter, that is 10 to the power 2 meter. So putting the value of this, so we get that is I1 by I2. So this is 10 tar square, that is 10 to the power 2. So the difference in intensity level, is that is 10 log 10 base I1 by I2. This is unit of dB. So 10 log, this is the value of 10 to the power 2 So this is 20 log 10 base 10. So we can write 20 dB. So we can write that is 20 dB. So intensity level, hence intensity level, that is 90 minus 20, that is 70 dB. Beta equal to 10 log 10 base I by I0. So this is 30. So 10 log 10 base I by I0. So we get that is I by I0 equal to 10 to the power 3. So I equal to 10 to the power 3 I0. So 10 to the power 3, this is the value of 10 to the power minus 12. So I equal to 10 to the power minus 9, that is watt meter to the power minus 2. This is then second case. So beta is the, that is 10 log 10 base, this is I by I0. So this is the value of I. I is given, that is 40 into 10 to the power minus 6 watt meter to the power minus 2. I0, that is 10 to the power minus 12 watt meter to the power minus 2. So beta, that is 10 log 10 base. So we can write 40 into 10 to the power minus 6 by 10 to the power minus 12. So we can write, so 10 log 10 base, so we can write that is 10 this is 5 so this is 10 2.0301. So 2 into 0.301, this is plus 5, so that is 56.02 decibel. So we have to calculate the distance, required distance. So beta is given, that is 10 log 10 base I by I0. So this is given, that is 40, 10 log 10 base, this is I by I0. So we can write, that is I by I0 equal to 10 to the power 4. So I equal to 10 to the power 4 into I0. So I equal to 10 to the power 4 into 10 to the power minus 12. So we can write, that is I equal to 10 to the power minus 8 watt meter to the power minus 2. Again I equal to P by 4 pi r square, this is 10 to the power minus 8 and this is 100. So 4 pi r square, so r square equal to, we can write, so r square equal to, that is by 4 pi So R equal to 2.82 into 10 to the power 4 amps meter. So this is the value of R. Next, that is intensity level, that is 70. We know that is beta equal to beta equal to 10 log 10 base I by I0. This is 70 is given 10 base log 10 base I by I0. Hence I by I0, that is 10 to the power 7, that is I equal to 10 to the power 7 into I0, that is 10 to the power 7 into 10 to the power minus 12. So I equal to 10 to the power minus 5 watt meter to the power minus 2. This is the value of, that is I. Again, that is in case of 60, that is putting, this is the beta, this is first case A, this is first case, second case B. Beta equal to 10 log 10 base I by I0. So this is 60, 10 log 10 base I by I0. So I by I0 equal to 10 to the power 6. This is the value of 10 to the power 6. So I equal to 10 to the power 6 into I0. So I equal to 10 to the power 6 into 10 to the power minus 12. So I equal to 10 to the power minus 6 watt meter to the power minus 2. So today we have learned different types of numericals relating to intensity. I think these numericals are helpful for all students in BSc level. Thank you all my dear students. Please watch all the videos and subscribe and like and share all to your friends. Thank you.